Hello everybody. Welcome. Man, I don't know why this radio station is so bad. Just the noises it makes is horrible. Maybe it's just the type of music it is. There's just really terrible quality that comes in, and I think it's the style of it. It's horrible. It's like a fuzzy sound. Let's just do something like this. So let's get started. So what are we doing? We're pressing F5, making a build go. And look at that. It doesn't build. That's what our plan is today. Get it to build. The plan. So, let's see what we're going through. So I left us off on a nice easy bit. And that is, so we can start here basically. That should do. Right. So, string intrinsics. Let's find the intrinsics. Right. So what we've got to do is get these type def and compound data types. The intrinsics to those guys. Right. Around, that's what I've done. Oh, right. Okay. That one's gonna be annoying. There's layers of this. Okay, let's start off with the easy ones. Up to half. Right, so these guys, we can give this treatment. We just got to get it exactly right. So they start from intrinsic type def start, and then it's type def index. Right. Ah, shoot. Intrinsic type def start plus HCC type def index underscore. That'll do it. Alright, that's those guys. Now there's still some more type defs to do, and that is let's find these. That is these scalar T's and P scalar T's. Well, they're scalar X's. It's a very terrible name, but that's the name for it for now. We can always change it. Very simple, find and replace. Yeah, so we need 3 layers of this. So, essentially, all of this oh shoot, it wouldn't work out. Damn it. They're pre-allocated string IDs, and string IDs are meant to be unique, right? So the contents is unique. So the issue I'm having now is like this name is actually the same for the intrinsic type def as well as for the intrinsic structure name. So we could just leave the structure name as nothing, but then that's a bit silly. But we could put an underscore as the C way, right, with all the type defs. That is possible. And then it keeps it the C way. Right, so I guess we'll just do it like that. But then typing it is just a little bit more annoying. So you say F32 times 2 underscore T. Ugh. Ain't so bad. Let's do it. Right. So what we need to do is we need to keep some of these anyway. So the type def, so we take them all. Just get these all right here and then we'll move on. So this sort of like alignment, this padding. There we go. So we copy all of these, because these can be used for the structure and the union definitions in just a second. But we need to make sure that our string table is initialized for the type defs. So it's going to be a similar sort of thing as we did earlier. So I'm going to press H to reflect it back up to the top. Not reflect, but sort of bring my cursor back up to the top while still highlighting everything I've highlighted. So it goes the other way now. Intrinsic type def start plus. There we go. That is them. I think. No, damn it. Scalar start T. Nearly there, it's fine. There we go, that highlights. So that is good. So you just want to do that for these as well. It's made really massive. Obviously we could have shown that to maybe like a macro, but oh well. Let's do that. Right. So that's the type defs in. Right. So let's go back to the string ID. So that's the intrinsic type defs, I think. Wait. We have to make sure. Vertex input T, right. Vertex input T. So what I was thinking about doing then is doing some nice names, I think. Well, not nice names, but doing some names that reflect the C way, right? Even though, yeah, I want this to be a very sort of pure C thing, as much as possible. Like, respect the standard library because we're trying to be like a standard library in a way, right? So we're just gonna keep that sort of style. Right, so there's those two there. They need to be type def. So we need pretty much this again, right? So I'm just going to take it and we'll just throw it in. That. Screw it. We done a bit. There we go. Cool. Right, so the next thing, that's all the type defs. So we could just say like, this is all the type defs. Intrinsic type defs, aka that. Okay. Right, so that's that section of code. Now the next section will be the intrinsic compound data types. They're going to pre-allocate string identifiers for in this lovely table. Damn it. Type defs. Compound data types. Yeah, so that's not any of these guys. These are fields, right? So they come later, so they'll be like misc. But all of these guys are that. So these are all the names for the structures and unions, so we're just going to find those in the string ID again. Right, so here's the string ID. We've just got this table filled up here with these guys. Now we're on this range of compound data types that start just after these type defs, and then they are as many as compound data type intrinsics count. And then these are the misc stuff. Well, maybe I can go and do that. Alright. Very nice. So let's get in there and get it sorted out. So here it is. So here's this piece of work. So we need a vertex input, fragment input, and a half as well. So those were up a bit, weren't they? Oh, they're in the type defs. Oh, they're here, good. So why are those at the end? When they could ideally be at the beginning with these things. Exactly. Much better. Right, so those need to go under here with us just to keep the same order, but technically they don't have to be in the same order, but we just like to do that anyway regardless. Cool, so... Right, back to the structure ones. Okay, so compound data type. Yep. Cool. Maybe a fragment version as well. So let's just do these two manually, or three actually, because I've got another one I want to do. And then, so it's without the T on the end. There we go. And then we do another one for half, because it's a structure. And there we go. Right, so they're the ones that are going to be done manually, the rest we can just do kind of automatically. Yes. That's what I was remembering. Okay, let's change that. Right, so P scalar, then scalar. So I tend to like to do P scalar first for some reason. And this... No, let's do the other way around. So because of that, I gotta remember things. Oh, it's structure than union, that's why. Right, so it's the other way around. Right, so scale these scalars. P scalars go first. For some reason. I'd like to keep it the same order though. Well, no, the packed ones do go first anyway. The packed ones should go first. And the reason being is because they're like that way in the header file anyway. So...
I'm sorry. I'm trained.
Hello everybody. Welcome. Man, I don't know why this radio station is so bad. Just the noises it makes is horrible. Maybe it's just the type of music it is. There's just really terrible quality that comes in, and I think it's the style of it. It's horrible. It's like a fuzzy sound. Let's just do something like this. Right. So let's get started. So what are we doing? We're pressing F5, making a build go. And look at that. It doesn't build. So that's what our plan is today. Get it to build. The plan. So, let's see what we're going through. So I left us off on a nice easy bit. And that is, so we can start here basically. That should do. Right. So, string intrinsics. Let's find the intrinsics. Right. So what we've got to do is get these type def and compound data types. The intrinsics of those guys. Right. I've just moved stuff around, that's what I've done. Oh, right. Okay. That one's gonna be annoying. There's layers of this. Okay, let's start off with the easy ones. Up to half. Right, so these guys are gonna get this treatment. We just gotta get it exactly right. So they start from intrinsic type def start, and then it's type def index. Right. Ah, shoot. Intrinsic type def start plus HCC type def index underscore. That'll do it. Alright, that's those guys. Now there's still some more type defs to do, and that is let's find these. That is these scalar T's and P scalar T's. Or the scalar X's. It's a very terrible name, but that's the name for it for now. We can always change it. Very simple, find and replace. Yeah, so we need 3 layers of this. So, essentially, all of this oh shoot, it wouldn't work out. Damn it. Because these strings have to be in... They're pre-allocated string IDs, and string IDs are meant to be unique, right? So the contents is unique. So the issue I'm having now is like this name is actually the same for the intrinsic type def as well as for the intrinsic structure name. So we could just leave the structure name as nothing, but then that's a bit silly. But we could put an underscore after it maybe. But yeah, it's a bit annoying. But you could put underscore T, right? That is the C-way, right, for all the type defs. That is possible. And then it keeps it the C-way. Right, so I guess we'll just do it like that. But then typing it is just a little bit more annoying. So you say F32 times 2 underscore T. Ugh. Ain't so bad. Let's do it. Right. So what we need to do is we need to keep some of these anyway. So they're type def, so we take them all. Just get these all right here, and then we'll move on. So this sort of like alignment, this padding. There we go. So we copy all of these, because these can be used for the structure and the union definitions in just a second. But we need to make sure that our string table is initialized for all the type defs. So it's going to be a similar sort of thing as we did earlier. So I'm going to press H to reflect it back up to the top. Not reflect, but sort of bring my cursor back up to the top while still highlighting everything I've highlighted. So it goes the other way now. Intrinsic type def start plus HCC type def index scalar start. There we go. That is them, I think. No, damn it. Scalar start T. Nearly there, it's fine. There we go, that highlights. So that is good. So you just want to do that for these as well. It's made really massive. Obviously we could have shown that to maybe like a macro, but oh well. Let's do that. Right. So that's the type defs in. Right. So let's go back to the string ID. So that's the intrinsic type defs, I think. Wait. You have to make sure. Vertex input T, right. Vertex input T. So what I was thinking about doing then is doing some nice names, I think. Well, not nice names, but doing some names that reflect the C way, right? Even though, yeah, I want this to be a very sort of pure C thing, as much as possible. Like, respect the standard library because we're trying to be like a standard library in a way, right? So we're just going to keep that sort of style. Right, so there's those two there. They need to be type def. So we need pretty much this again, right? So I'm just going to take it and we'll just throw it in. That. Screw it. There we go. Cool. Right, so the next thing, that's all the type defs. So we could just say like, this is all the type defs. intrinsic type defs, aka that. Okay. Right, so that's that section of code. Now the next section will be all the intrinsic compound data types. They're going to pre-allocate string identifiers for in this lovely table. Damn it. Type defs. Compound data types. Yeah, so that's not any of these guys. These are fields, right? So they come later, so they'll be like misc. But these guys are that. So these are all the names for the structures and unions, so we're just going to find those in the string ID again. Right, so here's the string ID. We've just got this table filled up here with these guys. Now we're on this range of compound data types that start just after these type defs, and then they are as many as compound data type intrinsics count. And then these are the misc stuff. Well, maybe I can do that. Alright. Very nice. So let's get in there and get it sorted out. So here it is. So here's this piece of work. So we need vertex input, fragment input, and a half as well. So those were up a bit when they're in the type defs. Oh, they're here, good. So why are those at the end when they could ideally be at the beginning with these things? Exactly. Much better. Right, so those need to go under here just to keep the same order, but technically they don't have to be in the same order, but we just like to do that anyway regardless. Cool, so right, back to the structure ones. Okay, so compound data type. Yep. Cool. Maybe a fragment version as well. So let's just do these two manually, or three actually, because I've got another one I want to do. And then, so it's without the T on the end. There we go. And then we do another one for half, because it's a structure. And there we go. Right, so they're the ones that are going to be done manually, the rest we can just do kind of automatically. Yes. That's what I was remembering. Okay, let's change that. Right, so P scalar, then scalar. So I tended to do P scalar first for some reason. And this... No, let's do the other way around. So because of that I gotta remember things. Oh, it's structure than union, that's why. Right, it's just the other way around. Right, so scale these scalars. P scalars go first. For some reason. I'd like to keep it the same order though. Well, no, the packed ones do go first anyway. The packed ones should go first. And the reason being is because they're like that way in the header file anyway. So, just, it's not really a thing you have to worry about keeping consistent, but it makes sense. I'm doing it like that. Alright, let's fix that one up. So that's the type def sorted out there. So, pack scalar x's, scalar x's. Okay, so now we've just got to actually get the names right. So here we go. Hey Balbuzz, how you doing? My teacher said that his co-workers are annoyed at him for not learning Python, and he just said, why learn Python if you know C? Yeah, that's what I would say, you know. That's what I would say. Like, why learn Python? Hey, no Dillo. Or no idea, lol. Yeah, it's going okay. I'm in a little bit of a moment where, well, end of last stream I was feeling like, project, but now, it's going okay. We got to the point where we was doing resources. I don't remember since last time you were here, but this, right, so what's the point in the to-do list when we was doing resources? And then there was a bunch of tech debt. So I decided to, because basically we required inlining functions for certain logic to work with resources, just the way, so we needed like an optimizer, so I wrote an optimizer, which was cool, to do inlining functions, but then it just got to the point where there was just tech debt building up. So I'm just going through the whole compiler and just dealing with all tech debt now. So we have the tokenizer working. Right, woohoo! And it's multi-threaded. Actually, no, I think I remember you seeing that bit actually. But anyway, so now we're doing the token generation, and then we'll be getting an AST working in. But what we're getting working first is all of the global declarations, right? Functions, structures, global variables, that stuff. Getting all that AST being generated first, and then we're going to dive into generating all the expressions. And I think I've got a really cool idea for how we can do a really packed expression tree in memory, because I've already kind of got one which is like 12 bytes per node, but it used to be 8 bytes per node, and then it had a bunch of errors. It's a massive project, to be honest. Yeah, it is. But it's going okay though. Like, but yeah, when we get this AST working again, that's the language. And then this stuff is basically like, you know, the IR, and then the SPIR-VGen. This is only per function basically, so it's not so bad. It gets a little bit easier as we start lowering down from here. But yeah, so yeah, it's going okay. Hey Red Fox, how you doing? Good to see you. Honestly, I think Python is generally pretty ugly. I think it's non-cellular. Yeah, it's just difficult. Like whenever I try to use Blender, whenever I try to use Blender and do some like Python plugins or whatever, it's I always find myself digging around to try and find, like digging around the documentation to try and find what type does what, and then like it's so difficult to figure out like what type a variable is as well. It's just so difficult. So yeah, it's big pain. Down the whole, there's the whole project development outline. It's really cool. Yeah. It's gonna be great. Just step by step, and just try not to get frustrated to the point where I want to throw the project away and never do it again, right? Just so I gotta like keep myself like get bits incrementally building, so I get feedback and then I'm happy, and that sort of thing, right? Yeah. Not bad, thanks. How are you? Yeah, doing good. Doing good, thank you. Pretty happy. Pretty happy. Yeah, doing quite good. Haven't done any coding on past projects in ages, sadly. Still stuck on my GUI lib. I really want to finish that. Yes, I mean, yeah, that's the one we did the rectangles, right? The dirty rectangles, isn't it? Mm. That'd be really cool. That'd be super cool. You can all static type in Python with a library like MyPy. But you can also statically type Python, but that's just a visual thing. Oh. I could have swore they were adding statically typed stuff anyway to the language as an option, right? I don't know if you're familiar with Lua. So Lua is the Roblox. Is that right? Roblox. I don't even know. Is it Lua? Is Lua L? Sorry, my brain's just having a bit of a brain fart. Right. It's Lua L, isn't it? Yeah, it's basically a typed Lua. So imagine TypeScript but for Lua. It's interesting, I guess, but they actually have it up on GitHub as well. Oh, Lua U. Huh. I wonder why I won't finding it. Maybe Lua L or R is like a Rust thing that I remember seeing ages ago, but yeah, it's like a typed Lua. It's actually a complete rewrite of the Lua compiler as well, I think. Well, I think they forked it and did some changes to it, but yeah. That's probably a better one to try and use rather than Python. Yeah, retain mode, backend agnostic, minimal delta rendering, pretty good. I don't understand why no one did it already. It's year 2022. I know that's what it's like with like so many things. So if someone's got an idea, and they say, and you know, you're saying like, oh, someone's going to get there before me, they're probably not. So just go and do the idea, and do it, because no one's going to do it. Basically, you're the person with the idea. But yeah, no, that honestly, that sort of like retain, well, backend agnostic, sort of like UI library thing. Yes, there's a few, I guess. You've got like WX widgets, is that it? But it's not necessarily something you embed in a game, is it? It's more of like a toolkit, maybe. Well, if you think that syntax is ugly, that foo colon int, if you think that's ugly, that's the new aged programming syntax there, my friend. Identifier colon then the type name. New aged programming. Oh yeah, and another thing is after I've got, oh, this is so long. I could squish that down into a macro. Yeah, another thing as well is after I've done this sort of cleanup slash refactor, whatever it's going to be called, whatever this is called, it does mean, oh, the repeat button is amazing. It means that this code base be a lot better for people who are wanting to contribute as well. So it'd be a lot better in that front too. I didn't realize that was a Visual Basic feature. I mean, not the personal original idea. When API does DirectX, in GUI is backend agnostic. Modern UI toolkits rely on the power of the GPU, but I say always performance on electricity, and it's supposed to be for applications, not for games. Right. Yeah, combine best of both worlds. Yeah, didn't didn't like most AAA studios, or not most, some move to using like C# to WPF for their tools. Like I used to work on some WPF stuff. Um, and yeah, it's got some really weird ideas with the whole sort of like, well, maybe the whole model view model thing isn't a bad idea. I don't know. I've not really investigated that one further, but just the amount of like over engineering people do for those applications is really crazy. Yeah, then you got Qt, isn't it, where it's like C++ and like really crazy to work with. Or you've got to use Qt Quick, which is some JavaScript, something that works with JavaScript, a JavaScript thing, yeah. Or MGUI, right? Yeah, MGUI is not so bad. Right, in a second I'll do it. Right, this should be it, fingers crossed. Hit compile. Right, fair enough. Yeah, it's a bit of like a toy type of thing. But it's really great just for whacking it in line with some code though, and just going and getting the debug UI. It's really great for that. Right, type def index scalar x. What is this doing? Ah, I see. Right. Use of undeclared intrinsic. What are you talking about? Damn it. Intrinsic type def start. Well, it's fine, I can just do a big rename. It's not a big deal. String ID. Oh, type def. It's a plural. No. Remember the S. Right, fixed up all of those. Let's keep going. Did it wrong again. Luckily enough, I've already got the search thingy-mabobbo, so it's not too bad, but intrinsic. Oh, I spelled intrinsic wrong. Right, we're good. Oh boy, what's this one? Array designator index 287 exceeds array bounds. Right, that's because That's because we were silly. Pretty sure we were silly. Yes. That needs to go there. So change the order. Alright, how does that look? Alright, now this one. How have I been a silly here? I've been a silly because that needs to go there like that. And then that needs to go there like that. Alright. Here's me like pre-allocating a bunch of like slots with an enum, just it's so error prone, but there we go. Right, what's the previous initializer? I think we've got a similar problem in the compound data types. Luckily enough, the compiler is so nice to give us this sort of error, so it's good. Seems pretty good. No, it doesn't seem pretty good. I take that back. Right. Okay. Does it compile? Yes, it does, but kinda not. What the? Oh. +1. Off by 1 errors. Exclusive ends. There we go. So. Yes. Technically everything compiles, but it doesn't link. So now it's just got some tables to fill in, or whatever it is, right? Some lookup tables to do. And then we'll got those in. We can run the compiler, watch it crash, burn, and die, and then we come along with the fire hydrant and put it out, I guess. Have you seen the video by Javid X9? I don't think what you're talking about over-engineering your code. It's quite funny, and I think you should watch it. You should get me a link, because I would love to watch that. Maybe we can watch it here, if it's not too long. By the way, quote I have from book, code can be so complex that there is no obvious bugs, or so simple that there are obviously no bugs. So the answer is harder to achieve. Yeah, it gets quite difficult though, because as low-level programmers, when you do stuff on like raw, when you do stuff that's at very low level, right? When you're building your abstraction on top of the operating system, some of that code is just inherently like if you're storing stuff, if you have like a chunk of memory and you're moving a pointer around and storing stuff at different places, and then in there, it's difficult to sort of like make that code look very very obvious sometimes. Yeah, you know, it's only 3 minutes. Just do this. Let's whack this up. All right, what can I do? Oh, you bugger. My computer's just too slow. All right, we're good. Very simple, very great, yeah. What's he gonna add now? Oh, I knew it. Come on, interfaces. Oh, templates. Yeah. Actually, no. His shape was already an interface, right? It was only virtual. Exactly. Oh, days. The cringe. Everything. Like, try and make all those balls and that. Like, give them enums for. Yeah, which is kind of interesting idea, but sometimes it's just obvious. Like, you just draw a false, right? Why put an enum there if you don't need to? Great. Oh. Here we go. Yup. Right, we'll get this music back on and we'll shall resume. Let's get the volumes. Have a bit of bad habit. Learn something to sneak in very quickly to give projects. Uh, very quickly you have to give projects a snap back to reality. Yeah. It's definitely very easy to over-engineer stuff. Or the worst one is like make it do stuff that you don't even need it to do yet. Um, and obviously sometimes it is a good idea to do that, and it does make it better in the future for sure. But other times it really just never ends up becoming useful. Um, so yeah, it's all yeah, it's definitely a thing you need to try and juggle and think about. Sometimes you need to try and think ahead a little more, right? Uh, but yeah, again, one big balance of things. Right, it's fun. It's fun the thing we need to put in, and I can multitask then. Uh, AML intrinsic data type scalar size aligns. Got it. Gotta find where this goes. It's in the AML thing, surely. Oh my days, what's that? Grep? It's in core. It can go in core. That is very true. Right. Up there it goes. So we just need the scalars. The scalars are obviously these guys. So I'm just going to do a pre-recorded macro that turns it into some string, but that'll to do it. Yeah, that's good enough. Right. So, we just want to, I guess... just hardcode it, screw it. Here's a quote from one of the AI leads at Google. Code isn't just meant to be executed, code is also the means of communication across... Oh, I think he said, here's a quote. Maybe I read that right, I don't know. Across the team, a way to describe to others a solution to the problem. Readable code is not a nice to have, it is a fundamental part of writing code. Code is about. This involves factoring code clearly, picking self-explanatory variable names, and inserting comments to describe anything that's implicit. Yeah, again, it's a very difficult one to do, right? If I write something new for work, I tend to put a block of comment, I tend to like block my code together and sometimes like put comments around it for me to catch bugs, but also just to help document like code as well as I go. Oh, thank you, sir. Thank you, another red one. Nice one. But yeah, I tried to do that. So although sometimes when I finished it, I'm like, there's way too many comments here, it's just fluffed it out, and really it's not as obvious, so I take it away. But it's difficult, because like, you don't want to describe like, you know, if there's so much like implicit knowledge that you pick up on, where if you were to document it, it's just your code base is going to be flooded with comments. Like, you program low-level stuff in C, this is the case. There's so many little tips and tricks that we use. If you just document all of them, your code's just going to be littered. And then you're going to have to wrap everything in a bunch of macros or functions, and then you've just got really like, you know. So really, sometimes it's good just to have a document that goes alongside the code base to say, well, if you see this in the code base, this is what it is, right? Rather than littering every place where it is used, and then making some functions for it. So it's, yeah, this is a constructor, exactly. Yeah. Sometimes you need to do that in C++ because you really don't know what's going on. But yeah, it's definitely like, again, one of those things where it's just difficult. The answer is just complicated. Right, so all the intrinsic compound data types. How these can get filled in. So, what we do is we have these, we have this structure called intrinsic compound data type. So in our standard library, to make sure that nothing goes out of sync and the user doesn't go, oh, my code doesn't work, or our compiler doesn't work, it just crashes. We validate everything that gets parsed up, so that never happens. Yes. So we have these pre-filled arrays with everything. So basically, I think we can just... Problem is, this includes like the scalar types, but we can skip those, hence why they're at the end. So really, we should probably call them like, we should have this like intrinsics checked count, and the checked count will go up to there, and the checked count is what this is going to be filled with, and therefore it won't be so big, right? Much better. So we go into the old code base and find that sort of stuff. This is in the AST section, maybe? I'm going to make these a lot better as well, these intrinsic functions. There's just so many. There's like literally 1,000 lines of these. And I'm going to reduce those down heavily. Maybe waste some enum space and just make it a lot less in terms of code. Yeah, doing good, man. Doing good. Yeah, had kind of an okay day today, but yeah, been okay. I'm gonna go do a bit of homework before end of bed. Good luck. Thank you. Good to see you. Right, AST stuff. Makes sense. So we're gonna grab these and go into the AST of the code. Right, so it don't exist in it yet. Shoot, what was that again? There's a section header, I just gotta find it. AST declarations, of course it is. Right, this one. Okay, so we actually do have this already filled out anyway, just in the old code base. We're gonna probably leave the function ones out just for now. Maybe. Or maybe we can think about that now. Well, not right now, but in a second. Intrinsic type defs. Oh, it's not the old code base, that's why it's still the current code base. Old code base. Gotcha. So I think we did a thing where, let's go to the parser quickly. So this is this new code base, generate type def. Oh no, I think we'll make these proper. Right, so these are, okay, these need underscore t at the end. The string ID, technically, I'm probably gonna do these as macros because, maybe. Yep. Well, UNAT, or sorry, just call it name. So we're just gonna fully uppercase name because it's meant to be fully uppercase. Glue that there. Then I think it needs to be like intrinsic type def start plus HCC type def index underscore glue on name, right? And then we want the last data type, which is the alias. And we put an underscore on the end just because otherwise it's going to replace the name again. And that's what that one is going to be like. Get rid of the comma because we need the comma. So then it will literally just be like this instead. Right, so we're going to like delete 3 words. might delete 5 words. Oh, wait a minute. No. 7 words. Alright, 8 words then. 8 words. There we go, finally. Right, very good. And then we just drop the end off. Right, so if you define void at the end, it means you literally do not care about what the type is, basically. But it is an intrinsic type, so it gets verified that it can be a thing. Right. So the rest of these are basically all those scalar ones, so I'm just going to delete these. And then we'll redo them. And then we'll undef this thingy mabob. Undef something like that. Very nice. So I'm just going to go and grab that list. So if we go to scalar x, very terrible name, but that's what they're called. Scalar x's. Where's these tables? It's in core, isn't it? It must be. Oh, it's in regular HCC. Got it. Oh, yeah, so maybe I should shorten these as well. They're just way too long, but I don't know. That's okay. It's okay. Right, so what I want to do is I want to grab the type def ones. Right. So these guys, they're gonna need their own enum. So they need another one. And this one needs to be like the scalar x. Just give it the word name. And we're going to want this sort of like this thing here to be also appended to that. So the name goes here, that'll be on AML intrinsic. Yup. And this whole thing needs to get appended here. Like that. Voila. Right, so there's also one called P for pact as well. So the pact goes first. But I might have just figured out that actually these are for the pact ones already, so that's already good. Cool. So we just need to just record a lovely juicy macro, which is just going to do it all for us. So we want to just go up to about here. HCC intrinsic type def P scalar x, put in the name and then the alias type. What's the type going to be? Alright, here's what we'll do. We'll delete that, all of that, and go back to start again. So that'll be, I don't know, I think it's about 40 odd, but let's do 38. Have a computer program for us. Yeah, right, so there's about 6 of those. Alright, so now we're down to about here. So we kind of need to record that again, I think, if I do it, is it... Still worked out okay. So what we're going to do is do, again, 44 of those. And then we're going to just delete the P off the beginning, and then that'll be all of those. Oh shoot, I forgot the P at the beginning of the other ones. Damn it. So I've got the P's on these guys. Let's sort this one out. So it's not gonna be that simple, is it? So 44, please. Right. So all we're gonna do is shoot over to the header file. We're gonna find where we declare these in the main header file. It's just below here, isn't it? Right. So we're going to just whack a whole load of... Oh, that is. Let's think about this one. This is type def as well, so you need the T's on the end. Right. Yeah. Okay, so let's just get all these nice macros in then for these. Wait a minute, I just remembered. This is the data type. That intrinsic data type is after it's been loaded into abstract machine language, but it doesn't represent the structure. So shorthanding that isn't going to be a good idea because it's two different meanings. So there's the non-load one when it's a structure, and the other one when it's not. So we do have this scalar x1. Which does help us get there and make it easier. So wherever we use this in the code already, I don't... Right, and that's always going to be hard-coded, is it? Probably not. You need the full type there anyway, but, so we should be able to concatenate that on there and it should be fine. Yep, so in this shorthand thingamabob we're doing here, we should be able to do that all in the macro, where we say alias data type is equal to, so we grab that scalar x thingamabobo, put that in there, and then we say, so we don't need the alias type on this anymore because the name is the thing, right? Hey, you the guy from the movie Child Killer. Okay. Name. That should be it. That's not the packed one. Let me go down. Right, so we've got about, so 40, well, my maths is terrible, so let's do 44, and then we'll repeat it again. And then I'll do 45. Oh, it's been 89, wouldn't it? There we go. Too late now. Right. Cool. So I do like that, what we've just done, right? It's made that a lot more tidy. So we could go and make that same sort of improvement to this one here, right? This very big thing here. So the way we'll probably do that is say like define HCC string intrinsic type def. So just do name like that, and then name like that, right? So we can just macro this, easy peasy. And then, so it literally just be like this, right? And you say concat name, and then you stringify name, yeah? And then we'll do another one, right? Because remember there's the scalar x's or p scalar x's, right? So just, I think it just needs this. Oh, wait. Cool. And then we drop the comma off the end, and now we can just transform all this data and make it look a lot nicer, easier to read. I don't know how it will affect compile times, but it doesn't really matter so much. It's not a thing that's worth worrying about. Alright, so what we should do is right, so we've got a macro for these guys, and we're just going to start the line. We're going to jump into about here. We'll keep going on actually, it's about there. HCC string intrinsic type def. Just put that in there. Delete that up to about here. Go to the end and finish that off first there. Right. Start a line again just in case for some reason. Then we've got about 12 of those guys. Repeat that please. Done. Now do the same thing again. But for scalar HCC string intrinsic type def p scalar x cool, so we've got about 44 of those. Oh no, what happened? Something got buggered up. It's okay, it's not so bad to amend, right? I think I had some sort of like padding, but then like, or something like that, I forgot what it was. But maybe the padding wasn't actually all in the same place, so it kind of screwed up, something like that. Right, so we could repeat the same one again, I think. Yes, but we do get a little bit off by one thing, but that's okay, we can just amend those. So we've got 45 of those, so it saves me recording another macro. And then we can just amend them pretty easily, I think. Fingers crossed. Looks pretty good, right? And then we just drop the P here. Gotta be careful, that one there, good. Alright, looking good. So now we'll do the same thing for the yes. Now I'm going to do the same thing for the compound data types. So these also have scalar x ones as well, so let's just sort that out. Something like that. Yup. So these kind of go off the page. Now it's going to bring them onto the page. Still a bit long, but it'll be okay. So you've only got 3 of these. I guess I'll do these 3, 3, know what happened. Oh, my macro got buggered. Oh well. Yeah, so I think we'll do the macro recording then. Well, this doesn't have to be a macro, it's pretty easy for these. HCC string intrinsic compound data type. Cool. Then these need the special treatment, so we go ahead and do that. So HCC string intrinsic compound data type p scalar x. Right, the padding could be off, so I think we want to do the word jump instead. That was the problem, I did it manually by moving one at a time. Now let's do it. Right, give that a go. So there's 44 of those. Hey Peter, how we doing? How's things going? How's the GPU lib going? Alright, the computer finished programming for us, which is good. So I think for these guys, we've got to drop this over. Refactoring is about 70% complete. Awesome. I wish mine was 70% complete. These don't really matter, to be honest. Screw it. Right, it's got to be correct. So p scalar. Oh, yes, that's what I was remembering. These have to end _2's. Right, 89 of those. Programming. There we go. Yes, that's a good thing. So now we just got to undef those because we don't really need them anymore, so just undef them. Very good. So undef all of these guys. Oh. Cool, so that's the shorthand stuff in there. Very happy about that. Yep. Right, so let's press F5 and see how much that compiles, see if we broke anything. We didn't break anything in the other table. Maybe we did. I don't know. No, we don't find out until... Right. I was in commented out code, that's why. We should add the void version, maybe. Make it easier to access that. Technically it's AST void though. Yeah, it's hard. I had a bit of a scare. Refactor version was around 25% slower, even with fewer effects. Turns out I had actually turned on shader validation. Without shader validation, it's blazing fast, and I think it's even fast. Will even turn out faster than it. It must be faster because, well, I can only speak from like Vulkan validation, but Vulkan validation is dog slow. Probably because they use standard string everywhere or whatever it is they're doing in the. They're probably doing all that. They like to write this stuff all in C++. All those Vulkan tools. I'm glad the Vulkan tools exist, but my days is the quality of it. Well, they do the good thing. They do good things, right? But the performance on them is not great. Yeah, that's pretty cool. What was the bit that made? I don't understand why. So, oh wait. Yeah, sorry, you're refactoring your game with your new GPU lib. Got it. That's interesting. So you really like slimmed it down then. Cool. So I guess this is a great win then. We'll see how it goes when you got it in fully, but seems like it has been a worthy thing. And not just a cleanup. Right, compound data types are next. There's only a handful of these guys. Let's go into the old code base. Right, get the old ones out. There's only 3. Str index, compound, data type index. Magic. So, there's a string ID. There's the fields. And then, see, I could do the lovely recursive macros. Or is it recursive macros? I don't know. I could do some macro hacks to make these far easier. And maybe it doesn't have to be recursive macros. Yeah, I can make this quite simple, I think, maybe. No, probably not. Probably not. Because of this. It's unique per thing. But you could have that. Let me see. Yeah, it's just the way it is. But this one can definitely be made better. Scalar X. HCC AML intrinsic. Float 32 times 4. Cop. Even if the final performance is slightly slower, this is a big win, if you think. It's all so much cleaner. Very nice. And also it's in your own little library. Maybe you already had it that way, right? But it's in your own little library. So long as you don't make that thing grow and it stays as simple as it can. Or maybe you find ways to make it even more simple in the future. You got a nice little reusable component there, which is nice. Right. In 32s. Yeah. We got a nice shorthand thing for that. Right, so these are like vertex inputs or vertex index and stuff like that. It's just a way to validate this stuff, so it means it doesn't go out of sync and we don't cry. This name, though, is a bugger. Because basically it's going to be compound, intrinsic compound, star plus wait, so if the names are going to be in the... Why do I need a string ID? Because we can just calculate the string ID anyway. Probably. But maybe we can't. Maybe we can't calculate it, so let's just put it in there anyway like that. Fragment. Half. Alright, see how much that compiles? Damn it. Compound data type index HC vertex input. Oh, I didn't miss the H. No, I didn't. Did you mean HC compound data type? Oh. Interesting. Right, so that'll be a lot cleaner now. Cool, so there's going to be some errors, but, you know, correct them. Ow. So after we got these in, we're going to forget about the function one just for a second. So the function intrinsics, just so we can get this compiling again. There's only a few things got to sort out. And we'll come back and sort out the function intrinsics and see what we're going to do in that front. Make it a lot cleaner and better. Right, back on AST Jeni. You already had a similar library I wrote previously, but it's pretty backped there. So that's how it goes. You need at least 3 rewrites before it's how it needs to be. Sometimes you need 7, but you need at least 3. Union data type. Yes, this is compound data type. Oh, no. Oh. It's in the internal header. Right. So there is a union star. Right there. Oh, right, but the thing it's referencing... Do we not have the internal header included? when we're making this thing, perhaps? Use of undeclared identifier. Oh, structure one. Got it. Right, that's the problem. Okay. So what's this one about? Well, that needs to have HCC by it just there. Thank you very much. This fragment one needs the same thing. Very good. Alright. Did you mean... Right. Luckily enough, that's inside of one of these guys, so I can change it at mass. Get rid of the T bit, and voila. Right, now it's got a couple of linker errors. So it's solved most of the linker errors. I think it's got one linker error left. So now we're going to go back. By generate variable decal. Oh, right. We might comment that one out. I don't know. We'll see. Yeah, so we should go back to the intrinsic functions now and really look at these. How do we want to do these? So this is the old code base, thinking about it, yep. So this is the old code base. It's a massive table filled with how these functions should be and whatnot. It's kind of good. And it does work. But I already filled it in. I think I had a what did I do before? Yeah, I think I recorded a bunch of macros and got this thing written out before, yeah. But let's take a look at the existing enum, see if we can reduce the number of lines of code in the code base drastically, because there's about 1,000 of these. There's a lot.